It's certainly my pleasure to be here with you this morning. I have only recently been introduced to the technical side of simulation and modelling earlier this year when I took over my current job. So I'm still learning, so it has been quite the steep learning curve over the last 8 or 9 months. But as Albert Einstein once said, as far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. So in support of this year's theme of the conference, using systems thinking to challenge mental models, I would offer that Albert Einstein's instinctive grasp of how systems did or did not affect each other challenged people's thinking models well before Bertalanffy published his general systems theory. So today I want to have a look at 3 different aspects of systems thinking. First is the impact of digitisation on the human aspect of military training. Then have a look at the role that complex adaptive systems thinking has to play in preparing future training options for the ADF. And finally, then have a look at... Okay, can you hear me now? Sorry. And finally, have a look at how chaos theory will have a part in preparing for and the conduct of hybrid warfare operations. So in my role as the Director General of the Australian Defence Simulation and Training Centre, I'm responsible for the development and implementation of joint simulation activities, but also for the planning and execution of joint collective training for the ADF. So the impact of emerging technologies and their associative cognitive trends has the potential to significantly impact how we train now and into the future. It has a subsequent effect on the maintenance of our operational preparedness and also our warfighting effectiveness. So the Australian Defence Simulation Training Centre, on behalf of the Chief of Joint Operations, sponsors the simulation product strategy for defence. And the strategy's vision is that simulation supports all defence activity and is seamlessly integrated throughout military and business operations. The strategy has 3 lines of operation: supporting defence's strategic objectives, employing the force, and technology and human development. The first 2 lines of the strategy provide the principles and mechanisms by which defence simulation users can coordinate and optimise the most efficient and economic use of the extant simulation resources. So this morning I want to focus on the considerations related to the 3rd line of the strategy, which seeks to identify, capture and exploit technical and human trends in support of simulation-enabled collective training. So in doing so, I want to concentrate on the implications of the human trends that develop as emerging and disruptive innovations are introduced. So a bit of background from my perspective about where my systems thinking and considerations of future complexity have come from. So for the majority of my career, I've been a user of simulation. Essentially, I've been a customer of the product. Now, I understand the technology dependency of the capability, but to me, I've always been focused on the impact on people, the impact on the humans around me, and of course, the training output. Now, whether it's been an individual focus or a demanding command team training activity, the utility of the technology to me has always been the effect on the cognitive processes of my team or my command. Simulation was one component of the whole training system, which has evolved and become more complex and adaptive as technology and human cognition has evolved. Digitisation has not only changed the technology of training systems, it's also changed the people and their cognitive processes within the training system. Over the years in both my personal and professional lives, I've witnessed and happily participated in the physical extension of Moore's law through the growth of digital technologies within the community. Technology has become part of our everyday activities, and many of us have readily accepted the change. Like many of you, my early thought processes were formed by essentially mechanical processes. I still remember having to use hard copy log tables, French curves and squares on graph paper to solve problems. Calculators, when they were introduced, represented an amazing advance in technology. But the children of the millennium who are now being recruited into the Defence Force have grown up with digitisation as a ubiquitous element of their culture. Their thought processes and cognitive regimes have been developed differently to previous generations. Digitisation has changed the millennial generation's information processing systems. Previously, the focus of education and training has been on the need to develop and maintain a complete knowledge of every subject. That is now transformed into a good general knowledge of all subjects and an intuitive capability to understand how and where to find the knowledge they need in an instant. This generation has an almost instinctive understanding of their world of it as a system of systems and their tasks as contributing to its complexity. They have an ability to rapidly adapt to new and emerging conditions without having to understand in detail the causes of the evolving environment. It's ancient history now, but Google became a verb in the Oxford English Dictionary in 2006. In 1998, when Google was launched, there were about 500,000 searches per day. Today, that has increased to over 3.5 billion searches per day by users. The sailors, soldiers, and airmen and women of the future expect their environments to be data-rich. They expect the information they require for any task to be easily findable. Academic articles have been published indicating that people using digital information networks can have an effective reading speed of 500 words a minute. However, they only process about 28% of that information. Their focus is on keywords, graphics, and readouts which relate to their current data discovery requirement. This enables them to choose the data relevant to their search and quickly solve problems without having to wade through masses of less relevant information. And those who might be unsure of a data discovery trail will undoubtedly have a digital social network which will point them in the right direction. Chat rooms are also an essential component of the technical architecture for the delivery of today's distributed simulation support to combined and collective training. Scanning and mining social media is a component of modern hybrid warfare, but using secure internal social media networks is an essential component for planning and commanding operations and exercises in hybrid environments. Defence has gradually adopted these procedures as part of the necessary ecosystem for operations. However, we've not always been as responsive to the future possibilities and more specifically, the future applications of employment of this technology. Similarly, our integration of virtual and augmented reality technology into defence systems is now starting to gather pace. The impact to defence capability associated with the emergence of more advanced technology and consideration of how socio-cultural trends would change with it are starting to be anticipated. Fourth and fifth generation platforms which are being introduced into service now and in the future represent complex systems of systems. For example, the air warfare destroyer represents a series of highly technical and complex systems, from the engineering plant to the logistics support programs, navigation systems, and of course the weapons and combat systems. However, these systems alone are not enough to meet the operational preparedness requirements. Our fourth and fifth generation platforms and the systems within them need to be built into capable, deployable operational forces. And of course, this adds another level of complexity. And when you include people into this technology ecosystem, and that not only includes us, that means our adversaries and third parties, it rapidly becomes apparent that an operational area is a complex adaptive system in which those operators who have better agility using systems will have the advantage. The incorporation of digital natives from the millennial generation represents an opportunity for defence to maximise the capability potential of new platforms and systems. However, to achieve this, we will need to review and adapt our professional education and training to ensure we encourage the new cognitive aspects of the digital generations. Now, from the perspective of the ADS-TC, augmented cognition is the likely human development from the implementation of emerging technologies which will have the greatest potential to drive development of simulation-enabled collective training in the medium to long term. Augmented cognition is effectively the expansion of human mental functions through the integration of human states with advanced computing systems. It's developmental and, by necessity, interdisciplinary and a natural expression of complex adaptive systems thinking. To effectively conduct these studies into advanced human and system integration requires experts in human interface, psychology, ergonomics, and computer sciences. Of course, there is also the requirement for engineers to hook all these systems together. Such expertise across a broad range of fields is often difficult to engage, particularly for extended periods of development and experimentation. A disruptive innovation which will be a component of this will be the development of human-machine interfaces, currently referred to as natural user interfaces. All of our current operational and training systems use what could be described as mechanical human-machine interfaces. Operators physically manipulate graphical user interfaces through keyboards, a mouse, or screen touch. The intuition for data sourcing or problem solving is purely the realm of the human operator. Interface technology has followed an incremental evolution, starting with the command line interface. Think of Windows 3 and DOS input systems, which had strict and effectively law-based interaction with the software. This evolved to our current graphical interfaces, which have had internal evolution stages and actually encourage the millennial data discovery trends. The emerging type of user interfaces will be more natural. They'll have systems which will learn the habits and needs of the operator, effectively learning how the operator conducts a task, intuit requirements, and bring to the fore additional information before it's demanded. Naturally, the marketing department in Microsoft is a bit more advanced than the engineering department in mastering the deployment of gesture, posture, and human state-based instrument control. But this lag between marketing and engineering presents an opportunity for defence. It's an opportunity to consider the implications of how best to use AI-based user interfaces. The United States Defence Advanced Research Projects Agency has been progressing an augmented condition program for the last decade. They've been specifically seeking to develop user-integrated multi-sensor interface technologies that will permit human state technology manipulation in real time. As a result, in 2015, the US Army Training and Doctrine Command developed their Human Dimension Concept Framework. This concept provides a framework for the optimal integration of human capabilities within the future technology environment to achieve superior warfighting effectiveness. Natural user interface technologies are recognised by both of these important development concepts as critical elements to the deployment of advanced human systems integration and the realisation of augmented cognition as a human development process. As new technology emerges, commercial personal devices and gaming activities will be at the forefront of this development. This means that the next cohorts of defence personnel will become personally adept at engaging with natural user interface ecosystems. They'll also expect the same level of integration in their professional environment. Defence will need to ensure it has considered the design requirements of both command and control systems and the training systems to support them in advance of their deployment to achieve maximum benefit from this technology. Now, that may not be a concern for the 2025 future, but it certainly will be a concern for the Defence Force of 2030 and beyond. These capabilities will be critical for the safe and effective conduct of training and operations, whether it be high-end warfighting, humanitarian aid and disaster relief, or domestic counter-terrorism. Only by taking a whole-of-systems view of the education, training and deployment functions will Defence realise the potential represented in these disruptive innovations, human trends and technology developments. So far I've talked about systems thinking and how it's essential to planning for education, training and operations. So now I want to talk a bit more about the series of complex adaptive systems. I want to consider how we can benefit from the consideration of chaos theory when applying complex adaptive systems thinking to hybrid warfare. The 2016 NATO review considers hybrid warfare to be a blend of conventional, irregular, kinetic, information and cyber warfare, as well as the weighting that the proponent places on any of these elements depending on the position taken in conflict. An aggressor may choose to focus on information and cyber operations to confuse legitimate responses to their actions. Defending and third parties in the conflict then have to respond within their choice of environment. And of course, in its naked state, hybrid warfare seems to be what high-end operations have always been, a complex set of interconnected actions and reactions, but now with more dense information, communication and cyber layers added. If a deployed joint task force, including its trailing logistics support elements, can be assumed to be a complex adaptive system, hybrid warfare is the ecosystem in which the system will evolve, change, thrive, or decay. And this has been the hallmark of any deployed force action in the past. However, now and into the future, the speed of action-reaction and the natural understanding on systems complexity by deployed systems operators will have to increase. This leads to consideration of chaos theory in current and future operations. And today I want to concentrate on state transition, which is the process where order transits to disorder. Military deployments are planned in great detail and seek continuous equilibrium in order that the plan can be executed and more planning done on the expected outcomes. State transition expects any system to become chaotic and then seeks to understand the process in order to return to equilibrium. Understanding the military state transition process gives us a much better opportunity to build in self-organisation, i.e., where the complex adaptive system can recover from a chaotic transition through internal means without waiting for or relying on external stimulus. A hybrid warfare aggressor seeks to create a constant state of uncertainty across all contested domains, seeking to create straight transitions in the adversary force or recovering from chaotic state more rapidly than the adversary. Advantage in the hybrid warfare ecosystem can be as simple as being able to avoid enforced state transitions and recovering from self-inflicted transitions more rapidly than the adversary can take advantage of them. Now, how do we achieve this simple operational advantage? The ADSTC designs simulation-enabled collective training exercises by integrating aspects of the 5 contested domains: land, maritime, air, cyber, and space. Hybrid warfare assumes the current and future operations must assume multifaceted threat lines with complex and uncertain physical and human geography. The intersection of interdependencies between the contested domains varies and can be fluid depending on the outcomes of each action in an operation. So how do we modify the joint training environment to encourage mental systems manipulation in fluid operational environments while also remaining within the bounds of command and control and rules of engagement? Currently, operators of command and control systems are trained to assess the threat based on information presented to them through their sensors and systems. While there are some automated data sharing processes between the systems and environments, the judgment process of what the likely outcomes are remain effectively mechanical. The simulation-enabled collective training activities provided by the ADSTC, or its descendant in 2030, will need to be sufficiently flexible for operators with evolved cognitive processes to explore their operational responses in a safe, low-risk and accessible environment. While there are emerging, maturing technologies which will allow the design, development and fielding of these environments, we can only benefit from them if the personnel operating them have a mental model that encourages agile systems thinking. Now, systems thinking has long been the academic province of engineers. However, as I've already highlighted, systems thinking through digitisation is becoming endemic to society. Therefore, our professional, military and academic education should incorporate elements of systems design and problem solving. What we do know for certain is the world is changing. Operational decision making has to become more responsive, has to be more instinctive, yet integrated with C4I technology. Digitisation has already affected human cognition and defence. A timely, effective response to the human component of these disruptive innovations within our day-to-day culture is essential if we are to succeed. Academic research into the effects of digitisation has identified that we should be looking to predict the human trends that are influenced by emerging technology. At the same time, we must better understand the system complexity associated with the fourth and fifth generation platforms soon to be introduced. We need to ensure our people are suitably trained to operate these platforms against a broad range of conventional and asymmetric threats. It's only through understanding emerging technology and its future operations, as well as the ability to maintain order, not chaos, that we can expect to not only keep pace, but gain a warfighting advantage in the contested domains of the constantly evolving future battle space. Ladies and gentlemen, thank you very much for your time, and I'll now take questions. Good question, well asked. I'm not sure I have the silver bullet answer to that one. All I can say is that we're doing all we can to ensure that our bureaucracy is limited, particularly in the introduction of the new capability life cycle. I think there are a lot of other areas too where we're trying to engage with industry through areas like the Innovation Hub, which was introduced, I think, December last year by Minister Pyne, to try and get the dialogue going with industry about what is available and how quickly we can overcome it. Are we good at it? No. Are we getting better? Possibly. We do have a long way to go, but if you've got any good ideas, we'd be very interested to hear them.
Just along those lines, Allison, I think the defence procurement setup is, at odds with the way we've got new technology. And as an example, I really like Australian Signals Directorate moving itself out of defence and becoming its own organisation now. They realise that, and they realise that under our current systems, they can't change technology-wise quick enough to keep up with their adversaries out there. So I would say that applies to the whole defence, and that's something that defence has to look at. Because even the capability life cycle is too long now, and things change on a yearly basis. Those cyber threats that are out there, we have to defend against, they're changing so quickly that our whole way we engineer things has to be changed. Just wondering what your comments would be.
And look, cyber is certainly an area that we are only just starting to begin to try to understand the changing nature of it. We've just established a new directorate to look exactly at that. However, it's embryonic. Are we behind the 8 ball? Probably yes. How we're going to overcome that, is the current capability life cycle going to be sufficient to address that? I think that remains to be seen. I think we need to give the capability life cycle a bit more time to actually bed down. It's only really been in for about the last 18 months or so. I think essentially we need a collaborative approach forward between defence and industry. Yes, we are enormous. Yes, our processes are slow, but there is a lot of work being done to try and overcome that. Cyber, however, and space is another example, are two areas where we're going to have to really apply a lot of resources to ensure that we, if we can, keep up but before we even think about trying to get ahead of the curve. Not sure if that answers your question, though. I'm not sure if I understand your question. So are you suggesting that what we're using, so trainers, we fight type model such that the same applications and systems that we use for training we use for...
In operations, so you've got commands may not be entirely over the 5 domains within systems theory, using simulation to provide a near real-time mapping and projection of events.
That is our plan for the future, so that we can do live, virtual and constructive simulated training at the same time. We have looked at doing elements of that in the past and it hasn't quite worked out as well as we would have liked. We're going back to the drawing board to have a look at how we might do that in the future, such that the live component understands what the simulated overlay is and understand the full picture, so that it's not a disjointed training environment. The answer to your question is yes, we're working towards that. We just have to work out what it's going to look like and how we'll implement it.